Hi everyone. My name is Yuzil, a current student at the University of Samratulangi Manado. Faculty of Mathematics and Science Course Information Systems 2018. But before starting the video, don't forget to click like and subscribe. Thank you. Hi. Now we will explain about what is graph and planar graph.
We hope you enjoy it.
Hi dude.
Hi, where have you been?
I'm from the park and I just heard something that made me curious about graph. Are you know about graph?
Really? You don't know about graph?
No, I don't. Are you know about graph?
Oh yes, I know about that.
Really? Can't you explain me what is graph?
Yes, sure. In mathematics, graph theory is the study of graphs, which are mathematical structures used to model pairwise relations between objects. A graph in this context is made up of vertices also called nodes or points which are connected by edges also called links or lines. Graphs can be used to model many types of relations and processes in physical, biological, social and information systems. Many practical problems can be represented by graphs. Emphasizing their application to real-world systems, the term network is sometimes defined to mean a graph in which attributes are associated with the vertices and edges, and the subject that expresses and understands the real-world systems as a network is called network science.
Wow.
Now, you understand about graph?
Yes, now I understand about graph. Thank you for explaining me about graph.
Yes, sure.
Oh no.
What's wrong?
I almost forged it. I must go back in house for make a dinner.
Oh yes, sure. See you later.
See you later. Hi dude.
Hi. Can't I help you?
Yesterday I had read about planar graphs, but I could not understand. Do you know about planar graph?
Yes, I know about that.
Can't you explain me about graph planar too, please?
Yes, sure. When a connected graph can be drawn without any edges crossing, it is called planar. When a planar graph is drawn in this way, it divides the plane into regions called faces. Notice that the definition of planar includes the phrase, "it is possible to." This means that even if a graph does not look like it is planar, it still might be. Perhaps you can redraw it in a way in which no edges cross. When a planar graph is drawn without edges crossing, the edges and vertices of the graph divide the plane into regions. We will call each region a face. The graph above has 3 faces. The number of faces does not change no matter how you draw the graph, so it makes sense to ascribe the number of faces as a property of the planar graph. If you try to count faces using the graph on the left, you might say there are 5 faces. But drawing the graph with a planar representation shows that in fact there are only 4 faces. There is a connection between the number of vertices v, the number of edges e, and the number of faces f, in any connected planar graph. This relationship is called Euler's formula. For any connected planar graph with v vertices, e edges and f faces, we have v, e plus f equals 2. Why is Euler's formula true? One way to convince yourself of its validity is to draw a planar graph step by step. Any connected graph besides just a single isolated vertex must contain this subgraph. Now build up to your graph by adding edges and vertices. Each step will consist of either adding a new vertex connected by a new edge to part of your graph, so creating a new spike, or by connecting 2 vertices already in the graph with a new edge completing a circuit. What do these moves do? When adding the spike, the number of edges increases by 1, the number of vertices increases by 1, and the number of faces remains the same. But this means that v minus e plus f does not change. Completing a circuit adds 1 edge, adds 1 face, and keeps the number of vertices the same. So again, v minus e plus f does not change. Since we can build any graph using a combination of these 2 moves, and doing so never changes the quantity v minus e plus f, that quantity will be the same for all graphs. But notice that our starting graph P2 has v equals 2, e equals 1 and f equals 1, so v minus e plus f equals 2. This argument is essentially a proof by induction. A good exercise would be to rewrite it as a formal induction proof.
Wow, that's awesome. Now I understand about graph and planar graph. Thank you for explaining me about that.
You're welcome.
Okay, now it's time to me back at home. Thank you for explaining me about graph and planar graph.
Yes, sure, no problem. See you next time.
See you.